In this video, we're gonna create a movie search application with Kotlin Multiplatform. It is a multi-module project in which we have a few feature module and also we have few core module that encapsulated all of the core logic in it. Talking about Kotlin Multiplatform, so it is a platform that provide us as a native Android developer to write our application in Kotlin that is executable on iOS target, Android target, and also desktop targets. During the building of our project, we will use Ktor client, we will use Koin dependency injection framework, and also we're gonna use here in architecture with MVVM pattern. We will delve into the core part of Kotlin multi-platform projects. We will try to understand how it will work for both platforms, and apart from this we also try to understand how all of our shared code base which we want to share across the platform will be compiled and executed for Android and iOS too. We will see how to use multi-module approach for iOS. We will also see how to use multi-module approach for Android. Apart from this, we're gonna see how to use navigation in both platforms. So it's a very different approach to do navigation for Android and for iOS, and we're gonna deep dive into it. Alright, so enough talking. Let's get started with our project and see how we can actually build this application. First thing first, we are going to create a brand new Kotlin multi-platform project. So to do that, just click File, New Project. These are the templates available. Scroll down. We have here Kotlin multi-platform. So just select, click on next. Here you can provide your project name, package name, save location where you want to save it, and the minimum SDK. And at the end we have build configuration language, and by default it uses Kotlin DSL, which is fine. Click on next, and here as you can see it checks Android, iOS, and in the UI implementation it selects Share UI. Now if you use Share UI, it will create a compose multi-platform projects, but we are interested in Kotlin multi-platform project. So the main difference between CMP and KMP is, in CMP we will use Jetpack Compose to write our user interface and it works on both platforms. In KMP it is not the case. We have to write Jetpack Compose UI for Android, and for iOS we will use Swift UI to write user interface. So I'm using here do not share UI, and at the end I'm gonna click finish. So it will create a brand new Kotlin multi-platform project within our Android Studio. By the way, I have already created a brand new project for myself, and this is the initial setup that you can get from my GitHub repository. Link is in the description box. Okay, so this is how Kotlin multi-platform project looks like. So we have here compose application. So this compose application targets Android platforms. This iOS app target iOS platform, and shared module is called umbrella module. So umbrella module is something which contains all of your shared code base. Like if you want to share your review model, you can put that thing within your shared module. And in this shared module source, we have 4 different directories. We have Android main. If you want to write something which is specific to Android, you can write it within your Android main. If you want to write something which is specific for iOS, you can write it here in this iOS main. This common main is the place where you can write all of your things which you want to share for both platforms. Let's say you want to take permission. So taking permission in Android is a different thing, and taking permission in iOS is a different thing. So both platforms have its own different approaches to take permissions. So at that point, you can write your permission taking logic for Android within this Android main, and for iOS within this iOS main. Sometimes we have to write few logic which is specific for Android and iOS. Now we are going to see its build.gradle.kts. So open this thing up. We have certain plugin. We have this Kotlin DSL, and it has our Android target just to target our Android platform. We have here iOS target, which will target the iOS x64, iOS ARM64, iOS simulator ARM64. So what it will do, it will create a framework naming shared. So shared.framework, which you can use within your iOS application. And if you have multiple modules, it takes everything, create a single framework naming shared.framework, which you can share to your iOS application. So that's the reason why we'll have this thing within our build.gradle.kts of our shared module. We have few source set where you can put all of your dependency. For common main, we have common main dependency, and if you want to do If you want to add some dependency for Android, we'll use here Android main dot dependencies. Similarly for iOS, we have here iOS main dot dependencies. Very simple. Scroll down, we have few things for our Android, like its namespace, compile SDK, compile options, and default configuration. So this is the project structure of our Kotlin Multiplatform project. Let me just sync it. Open up your compose application which will target our Android. So here you can see we have build.gradle.kts, just like we have with our native Android projects. We have plugin, we have Koin DSL, Android target, we have few source set, we have Android main dependency, common main dependency, common test dependency, and within this we don't have iOS main dependency because this is specific for Android. Okay, scroll down. We have all the configuration. As you can see over here, we have our namespace, compile SDK, our default configuration, which have application ID, minimum SDK, target SDK, version name. We have packaging resources, build types, compile options, and the dependencies. I think we are very much familiar with this structure because we are native Android developers, so we knew how our build.gradle.kts looks like for native Android. Let's open our iOS application. So in our iOS application, we have iOS app.swift. So this is the entry point for iOS application. It uses this content view. So this content view present over here, you can see. So this content view extends view and it defines view user interface, of course. Okay, so we will see all of these things later when we deep dive in our iOS platform. So for the time being, we are pretty much done with the project tour. Now it's time to start our journey. So in our application, we're gonna create a movie search app, right? And in this movie search app, we have two features. The first feature is search feature and the second feature is detail feature. So let's create few modules within our Kotlin Multiplatform project. So for the time being, Android does not provide you any direct way to create Kotlin Multiplatform module. We need to create it by ourselves. So usually I prefer this approach. I'm gonna create a directory. So first is for our core network. Next we have feature module features, and in this feature we have two features, as I already said. We have search feature and we have one more feature naming details. And in this search feature we have three layers: data, domain, and presentation. By the way, we are going to follow here MVVM with clean architecture. So in clean architecture we have three layers: data, domain, and presentation. Data is responsible to get data from remote or local data source. Domain layer is responsible to create use cases. And lastly, we have user interface, or you can say presentation layer. So responsibility of presentation layer is to present data to our user. And within domain, we also write our business logic. Okay, so now in this search, we're gonna create three more directories. So first is for data. Next, we have domain. And lastly, we have our user interface. Some people say UI, some people uses presentation, so it's totally up to you, and I like UI more. So copy this thing, paste in your details. So we have two features, search feature and detail feature. We have our core network. Now in order to create this directory in a form of module, we need to add build.gradle.kts for each module. So for the core network, I'm going to create a file, and the file name is very specific, which is build.gradle.kts. Scroll down, open your shared module, build.gradle.kts, just copy all of this thing and paste in here. I think this is a very easy way to convert your normal directory into modules. Okay, all the things are looking fine to me. I'm gonna remove this thing because I don't want to create more than one framework. I only want to create share.framework, which will share to our iOS application. And if you use this approach in more than one modules, eventually you will get a compile time error while compiling for iOS. So just remove all of these things and left with iOS x64, iOS ARM64, and iOS simulator ARM64. So it will generate the Kotlin libraries, which further converted into shared framework. Okay, scroll down and change this namespace. So instead of using here shared, we will use here core network. Okay, And yeah, we are pretty much done. Now scroll down, go to your settings.gradle.kts, scroll down, just include this directory. So directory name is core network. Sync your project. As you can see, now our core network directory will eventually become a module for Kotlin Multiplatform project. Now in this, I'm gonna create a directory, and this time we have a lot of suggestion. So mostly we'll use here common main, or you can say shared logic. And in this Kotlin, I'm gonna create my package, which is dev Himanshu. This is a core network, so I'm using here core network. So this is my package. Just like this, I'm gonna create build.gradle.kts for all of my other modules. So just copy this stuff, paste within the data, scroll down and change this core network to details data. Okay, copy this build.gradle.kts and paste within your domain and change the namespace from core network to details.domain. Similarly, paste within your UI, and in this UI just change the namespace details.ui. Okay, scroll down, go to your settings.gradle.kts, duplicate it. So we have features, colon details, we have data, duplicate it, we have domain, duplicate it, we have user interface. Remove this core network and sync your project. After syncing, you will see all of your directory, normal directory will eventually become a modules. There is a spelling mistake, details. Copy this, paste here and here too. Again, sync your project. Right, so as you can see, now we have details module that contains 3 layers: data, domain and UI. Similarly, I'm gonna copy this build.gradle.kts, paste within our search data. Copy this domain, paste within our search domain, copy this UI and paste within our search UI. Open your data layer build.gradle.kts, scroll down, and instead of using here DLs, use search. Okay, so we are done with the data. Now for the domain, just use here search. For the UI, just do the same thing. Change the namespace to search. Okay, scroll down, go to your settings.gradle.kts and just duplicate this thing. Now change this detail to search. Copy this stuff, paste and paste. Sync your project. Alright, so now we have search, data, domain and UI layer. One more thing, I need to change this spelling mistake. Just change this thing in your domain. Domain in fine, in the UI it is fine. Okay, sync one more time and now we are good to go. So we will start our journey with core network module, but before that let me show you the API that we are going to consume in this project. You can go to this particular website. This is their landing page. Log in yourself, and after that just click on this more. We have here API documentation. So when you click on it, you will see this kind of user interface. And when you click this API references, you are going to see this particular page. Now in this page, we have all of the endpoints that is provided by them. One more thing, when you register yourself, you will also get an API key. So here you can see in the header, it uses authorization bearer, and after that it uses the generated token, which is generated specifically for me. And we have a lot of APIs in this, and I'm going to show you which one we are going to consume. So first, just click Ctrl F and type search. So in this search, we have movies, and this is our first endpoint. So just copy this endpoint, come back to our project and paste it somewhere. So in the core network build.gradle.kts, I'm gonna just simply paste it. Okay, open your core network, and in this core network, we're gonna create few packages. So first package is client. By the way, we are going to use here Ktor client to communicate with our backend APIs. We'll require one more package which contains the information about my services, and one more package just to store our DTOs, or you can say models. Alright, so go back to the website. Here you can see we can try it out. Just type here Harry. Click on this try it, and this is the response structure. Scroll down, just copy this response structure, come back to your project, and in this model I'm gonna create model classes corresponding to this JSON. So right click, new Kotlin data class file from JSON. By the way, this is a third-party plugin which you can install from marketplace. And in this I'm gonna paste it and call it search response. Open your model. We have two data classes. First one is search response and second we have result, and I'm gonna convert this name from result to movie DTO. And in this movie DTO, I'm gonna remove all of the parameter which we don't use in our project. Like we don't use adult, backdrop path, genre ID. Also we do not use original language, original title, overview, popularity. We do use this poster path, and after that remove this release date, and also remove this video, vote average and vote count. And if you want to use this movie DTO with Ktor client, we need to make it serializable. So to do that, open your build.kl.kts, and here we need to attach our Kotlin x.serialization. Also we need to use here plugin in front of our Kotlin. Okay, let me show you the libs version toml file which contains all of the dependency that we're gonna use in this project. So this is my libs version toml file. Scroll down, we have here few compose material thing. We have KMP observable view model core. This is a third-party library which help us to expose our view model in both platform very easily. For iOS, it will eventually convert your view model in a form so that you can very easily use this view model in a form of state objects. We have here material, we have few Koin dependency, we have coil image loading library, we have Ktor client dependency, Kotlin X serialization, and the navigation for Android specific, or you can say for Android. We have Kotlin test, Android core KTX, few Android X dependencies. We have Android X compose, BOM, or you can say platform dependency. And when you scroll down, we have certain plugin like Kotlin X serialization, native coroutine. So this native coroutine is used to expose your state flows very easily in iOS platform. So it eventually converts all of your state flow in a form of async await so that you can use it very easily in your iOS site, which we will see later. We have KSP and room. By the way, we are not going to use these two, but still let it be. Go back to your search response, and in this build.kl.kts we have already added Kotlin X serialization plugin. Now we are going to add Ktor client dependency. So for the Android, we'll use implementation libs Ktor client for Android. In the iOS main, we'll use this same implementation libs Ktor client for iOS. Now in the common main, we're gonna put all of the dependencies which we gonna use in our common main directory. So we'll use here libs.ktor.client core. We have one more dependency which is related to Ktor client. So Ktor client content negotiation. We have one more dependency, libs Ktor client serialization. Okay, sync your project. Alright, syncing is done. Go back to your search response and just simply use here serializable. Make sure your movie video also uses this serializable notation. Okay, so we are done with this model classes. Now it's time to create our HTTP client, or you can say Ktor client. Right click, new Kotlin class / file, and I'm gonna call it HTTP client, and in this we have a function naming get instance. Return type of this function is HTTP client. Make sure this HTTP client is coming from IO Ktor client. Return HTTP client, use here pair of parentheses, and within this we can install all of the required thing which we want to install within our HTTP client. So first I'm gonna install the content negotiation. and we're gonna negotiate content in a form of JSON. This JSON is coming from this particular library. Okay, and in this JSON we're gonna write few modifications. So just use here JSON, and in this JSON we have ignore unknown keys to true, because if you noticed in our model I have removed a lot of parameters, and if we don't use this particular modification our application will crash because we have removed few parameters from our data classes. So go back to your HTTP client factory. We are done with this installation. Next we're gonna install the timeout. So we have here HTTP timeout. We have three different types of timeout in here. First we have a request timeout millis. Next we have socket timeout millis, which is I'm using a 3 second, not 10 second. And lastly we have connection timeout in millis, which is also 3 second. Alright, next I'm gonna install my default request. So let me just copy the API endpoint, scroll up, this is our API endpoint. Simply copy this, come back to our project and paste in here. Again go back to this website, and this is my token. So just I'm gonna copy this complete token, come back to our project and paste it. Okay, so now we have our authorization token, and also we have the API endpoint. Now within this install I'm gonna give all of the information regarding my endpoint. So within our host we're gonna pass this thing API the moviedb.org, because this is the host. And next we need to pass the protocol. So use protocol URL protocol, and we'll use here HTTPS. As you can see over here, protocol is HTTPS. Next we need to attach this authorization header. So for that simply use header function, and in this header function we have HTTP headers authorization. This is coming from our Ktor client. Okay, simply use this token, and in front of this token use bearer, because as you can see in the website it uses bearer, and after that it uses our token. So similarly I'm gonna use bearer, and after that we have our token. Okay, so that's it. This is our basic setup. So first it uses the api.themoviedb.org as a host, and protocol is HTTPS. So this block contains the information about our base URL, and after that it uses this header. So this is our default request, and we are pretty much done with our HTTP client. Next I'm gonna create here a package for dependency injection, and after that I'm gonna add my Koin DI implementation, or you can say the dependencies. So libs koin.core sync your project. Okay, syncing is done. Now in this service I'm gonna create a class name is movie API service, and in this class I'm gonna inject my HTTP client. We have here function, suspend function, search, mention the query, and the return type of this function is result, and this result contains information about list of my movie TTO. And in this function I'm gonna use here try catch, because we are going to perform a network request and sometimes it might throw an exception. So if it is a case I'm gonna catch it and use result.failure and pass my exception. Now in this try I'm gonna use my client. We have here get method. As you can see, this is a get method. Over here you can see movie get. Come back to our project, and in this get we need to pass the first, let me import this thing, and after that we will pass the endpoint. Go to HTTP client factory and simply copy this stuff, come back to your movie API service and paste in here, so that it's very easy for us to take reference. So our HTTP client knows about this. Next we need to mention this. Okay, so we have here three. We have search, we have movie. Now in this we're gonna attach few parameters too, because in our API endpoint we have query, and this is a required parameter. Come back to our project and add it, query, and pass our query. Done. So this will hit our backend API, and we are interested body of type search response. So now we have search response, and we'll use here result.success search response, and search response contain the result, so simply use it, and in front of your try you can return the information. Alright, so we are pretty much done with the first API integration, which is search. Next we're gonna integrate the second API, which is actually used to get the information about a particular movie. So I'm using a suspend function, get movie details, and now we're going to write the implementation. But before that, let me show you the endpoint. So just search for details in here. Okay, so as you can see, this detail is present within our movie, and this is our endpoint. So copy this endpoint, come back to our project, and now simply use client.get, and in this get just mention the endpoint. So this endpoint is 3 movie slice, and after that we will pass our ID and the body API endpoint, and try one of this movie ID information. So just use here 671 movie ID and try it. Okay, so we have this information. Now scroll down, copy this information, come back to your project and create model corresponding to this JSON. Kotlin data class file from JSON, paste the information and call it movie details response. We have movie detail response. So this is the response which is actually used by our second function within our movie API service. And I'm going to remove all of the information. We are only dealing with few information. We are only interested with this information. Now use here serializable, and we are good to go. Go back to your movie API service, and the return type of this body is movie detail response. Okay, because this is an API call, we need to use here try catch. Cut this thing out and paste within our try. So we have here movie detail response. Use result.success and pass movie detail response, and in this exception I'm gonna use result.failure, pass the exception. In front of try, use return, and the return type of this function is result of type movie details response. Within our movie API service we have two services. First one is used to search the movies, and second one is used to get the movie details. And now we are going to use here dependency injection. So in this DI I'm gonna create a file, and the file name is core network module. We have a function get core network module. A return type of this function is module. Use return module, create a single instance of our movie API service, import it, http client factory.get instance. Alright, so we are pretty much done with our core network module. Just close it, and now it's time to begin our journey with features. So first we will begin our journey with search feature. So in this search data I'm gonna create here directory common main, and in this let's create a package dev himanshu dot feature name is search. So use here search, and layer is data, search data. Okay, so now in this search data I'm gonna create package for DI. Next, just jump into our domain layer, because domain layer is an independent layer that contains our repository interface and use cases, and this repository interface implementation will be given our data layer. So within our domain just create a directory common main, And in this common main, again we need to create here package, which is dev Himanshu. Feature name is search, so use search, and layer is domain, simply use here domain. Okay, so now in this first we need domain layer model package, we'll need repository interface package, and also we'll need the use cases package. So first let's create model. So right click, new Kotlin class / file, and I'm going to create here data class, and the data class name is movie. In this movie we have ID, we have title, and we have the image URL. Type is string, just use your small t. Okay, now I'm gonna create a repository interface, and the interface name is search repository. And in this interface we have only one function naming search, pass the query information, and return type of this function is result list of movie. This movie is coming from our domain layer. Alright, so we are done with this interface. Now it's time to write its implementation. So this implementation is given by our data layer, because responsibility of data layer include this part. So now within our data we'll create one more package naming repository, and in this repository I'm going to create a class, and the class name is search repo implementation. Just use here search repository. This search repository is not available in our data layer because data layer module is not connected to our domain layer. So let's establish a connection between them. Go to your build.gradle.kts, scroll up, and in this common main I'm gonna use your implementation projects features search domain. Sync your project. Alright, so it's done. One more thing, we'll need here Koin dependency injection framework. So koin.core, again one more time sync it. Okay, so now go back to your search repository implementation. As you can see, now it is available, so import it. Now in this search repository implementation we're gonna use our service, which is movie API service, and again this is not available, so just establish connection between our data layer with core network. Just duplicate it, use your core network, sync your project, go back to your search repository implementation. After the sync you will see this movie API service is available. Just press Ctrl I and override search. Use return service.search, pass your query. So the return type of this function is a result list of type movie, but as you can see the type that we are receiving from this service is a list of movie DTO. So we need to map it. So for that we'll use here map. So this will provide me list. Again I'm gonna use here map on this list. Now this time we have our movie DTO. Use movie, make sure this movie is coming from our domain layer. And now we are going to specify all of the remaining argument by name. Just simply use your DTO ID, convert this thing in a form of a string. Next we need to mention the title, and lastly we need to mention the image URL poster path. So this poster path only contains the last endpoint of the image URL, so we need to create a function which will complete this image URL. So to do that, within our search repository I'm gonna create here a private function build image URL, and simply pass the path, and the return type of this function is string. So if our path is empty, we'll simply use here empty string, otherwise we will create an image URL. So this is the image URL, and we are getting this particular path from this poster path. Just copy this thing, paste in here, and at the end simply append the path. Okay, so now we have our image URL, simply use it. So build image URL DTO dot poster path, and sometimes this poster path comes null, so use here nullable. go back to your search repository implementation and handle this case. So if it is null, I'm gonna pass empty string within our build image URL, return it. Okay, so now we have our list of movie. Okay, so now we are going to write dependency injection module for this layer. This is a file, and in this file we have our search data module. Create a function naming get search data module. A return type of this function is module. Make sure this module is coming from org Koin core module. We'll use a return module, and I'm gonna create a single instance of this repository. Okay, import search repository and search repository implementation. So we are done with our data layer for search. Now go back to your domain layer, and in this domain layer we're gonna create a use case, and the name of this use case is search use case. We're gonna inject our search repository in it. We're gonna create a function naming execute, pass the query, simply use search repository dot search, mention the query. So search is a suspendable function, so for that I'm gonna use here suspend function execute. Now we will create a package for dependency injection, and in this dependency injection we're gonna create a file, and the file name is search domain module. Function get search domain module. A return type of this function is module. So this module is not available, need to add dependency for that. Scroll up in the common main. I'm gonna add dependency for Koin core sync your project. Come back to your search domain module, and after sync module is available. Okay, import it, return module, and this time I'm gonna use here factory. So factory will create a new instance every time when you want to inject it. So we have here search use case and inject the repository implementation. Alright, so we are done with our domain layer. So we are pretty much done with our data layer, and we are done with our domain layer. Now it's time to begin our journey with UI. So in this UI I'm gonna create a directory common main, and in this common main I'm gonna create my package, which is Dev Himanshu search UI, and in this we will create our view model. So the name of our view model is search view model. Now we are going to add few more dependencies. As I told you, we're gonna use a library which help us to expose this view model in a form of state objects in iOS side. So to do that, open your build.gradle.kts, and at the top add the plugin. So the plugin is native coroutines. One more thing, later on we're gonna use Android main to write our composable. So I'm using here lips compose compiler. Later on we will use it. Scroll down, and in the common main I'm gonna add dependency. So implementation lips KMP observable view model dot core, dependency for our Koin core, and also we're gonna use here view model qualifier. For that we'll require one more dependency from Koin side. So Koin compose view model, and we have Koin compose. Okay, sync your project. We need to add one more thing which is mentioned in the KMP observable view model core GitHub repository, which is this. Okay, sync your project one more time. Alright, so we are done. Now go back to your search view model and extend this class with view model. Make sure this view model is coming from com dot, I don't know what was the name. Now we're gonna create a UI state. So right click new, and the name of this class is search UI state. This is a data class, and in this data class we have is loading naming boolean, initial value is false. Then we have error, type of this thing is string, And lastly we have the actual data, which is a list of movie. So this movie is present within our domain module, so we need to make connection between these two. So go to your build.gradle.kts and simply do the same thing which we did for data layer. So we used to use here projects, we have feature, search, domain. Single project, go back to your search UI state, and after the sync this movie is available, so import it. It's a nullable, initial value is null. Go back to your search view model, and over here we want to create a private variable underscore UI state mutable state flow. Make sure this mutable state flow is again coming from the same package which we have already been used for view model. Import, as you can see we have to import. The first one is coming from Kotlin Lex coroutine, which we are not going to use. We will use the second one. And within this we need to pass our view model scope and the initial value of this thing, which is search UI state. Just below to it I'm gonna create UI state, which we will expose it. Type of this thing is state flow. Mention the type, which is search UI state underscore UI state. Similarly, I'm going to create a private variable which holds the information about my query. Use mutable state flow. Make sure this mutable state flow is coming from the same package. This we will pass our view model scope, and its initial value is empty string. Just below to it, I'm going to create a query. Type of this thing is state flow string, and we'll use the mutable state query over here. Alright, so now we're gonna create a function naming update query, and we'll pass our query which user entered in our text field, or you can say in search field. Use our query and update its value. Now I want to expose this state flow to our iOS application. So in order to do that, we're gonna require here an annotation naming native coroutines state. Import it. Copy this stuff and just paste on top of our query. So now we have here init block, and in this init block I'm gonna use my view model scope, launch a new coroutine. We'll use our query. First we're gonna use filter it is not empty, and after that we will use here debounce just to produce throttle of 500 millisecond. After that we will check distinct until change, then only we're gonna collect the latest emission in a form of query. So if it happens, we're gonna simply use our use case. So simply inject that use case within our search view model, and the name of that use case is search use case. Import it, scroll down, and in this collect latest simply use search use case, execute, pass your query. Use on success will retrieve the data, and if it is not the case we will end up in failure. Grab the error message. So if it is a case of error, we'll use UI state update, use search UI state, and pass the error message, which is coming in a form of error.message to string. For the success, we'll use our UI state update, search UI state. In place of data, you can simply pass the incoming data. Okay, so at the starting point, when user types something and will come up to our collect latest lambda, we'll simply update our search UI state is loading to true, so that we can simply show a circular progress indicator to our user. And yeah, we are pretty much done with our search view model. Now it's time to use dependency injection to inject our search view model in Android platform and iOS platform. But here it is not that much simple, because view model is something which is platform dependent. For Android we have lifecycle event, for iOS we have few different things. Of course, we can create here a package package name is dependency injection, and in this I'm going to create a file, and the file name is search UI module. We'll use here expect function get search UI module. Return type of this function is module. Now we are going to write its actual implementation in Android platform and iOS platform. So as you can see, it give me a suggestion, create missed actuals. Click on it, just select your iOS main and Android main, click enter. So as you can see, now we have Android main, and also we have here our, okay, so it didn't create implementation for iOS. So go back to your search UI module, just click one more time, create missed actuals, iOS main, and now we have iOS main. Okay, so let's write first for our Android. So in this Android, we're gonna use module, and in this module we have view model. So this view model, make sure is coming from Koin dependency injection framework. Use your search view model instance and inject your search use case, return it. So this is done for the Android. Similarly, go to your iOS main dependency injection search UI view model, and on the top I'm gonna create here private val view model module, and we'll use here factory search view model inject my search use case. Use this view model module and simply provide it, return view model module. And at the end of this, I'm gonna create here a class, and the class name is search view model provider. Extend this thing with Koin component. We have a function naming provide search view model, and return type of this function is search view model. Simply use here get. Make sure this get is coming from Koin dependency injection framework package. Import. As you can see, we have a lot of option, and we are interested in extension over Koin component get. So the first suggestion. Alright, so we are done with dependency injection framework, which is actually used to provide our search view model for Android platform and for iOS platform. We are pretty much done with it. Now it's time to initialize our Koin dependency injection framework for both platform. So to do that, just minimize all of these things. Go to your shared, and in this shared build.gl.kts, we need to add dependency for Koin. So we will use here implementation lips Koin core. Sync your project, open your source. So first we are going to set up for Android. So open your Android main, and over here I'm going to create base application. This is a class which extend application, and in this application we'll have here on create naming function, simply override it. Okay, so now it's time to register this base application within our Android manifest. So open your compose application, source Android main, open Android manifest, and simply mention your base application. One more thing, simply take internet permission. Alright, scroll down. We are done with this base application. Now it is good time to create a function naming init Koin, which we can use it to initialize Koin dependency injection framework for both platforms. Because we want to share this information in both platforms, we can create that information within our common main. So in this common main, I'm going to create a package naming DI, and in this DI, we have app DI setup naming file. We have here init Koin, and in this init Koin, we'll use start Koin, and we simply mention all of our modules. So first module is core module. This functions is present in the different module. We need to establish a connection between all of these modules with our shared module. So open your build gradle KTS, and here in the common main, I'm gonna use API projects.core network. You will know why I'm using an API instead of using implementation. We'll discuss it later when we are dealing with iOS application. So just duplicate it. We have our features.search data, duplicate it, we have domain, and lastly we have our user interface. Remove it, duplicate it, we have details UI, we have details domain, and at the last we have data. We are done with it. Sync your project, go to your app DI setup, and now get core network module is available. Similarly, we have get search data module, get search domain module, and lastly get search UI module. Okay, so now it's time to use this init Koin function. First, for Android, go to your base application, and over here we'll use init Koin. Similarly, for the iOS application, scroll up, open the iOS application, iOS app, iOS app.swift. This is the entry point, as I have already told you, and in this we're gonna use init block. And in this init block, first thing first, we need to import our shared module. Now in this init, I can use my app DI setup KT do init Koin. So this is used to set up Koin dependency injection framework for iOS platform. I think we are good to go with the UI layer of our search module. So open your feature search UI module. So first we're gonna create our application for Android platform, and after that we will create this application for iOS. So in this Android, first go to your build.il.kts. Now in this Android main, I'm gonna add dependency for my compose. So we have here compose material, duplicate it. We have Android X dot material 3. Okay, sync your project, go to your Android main, and now I'm gonna write its screen. So right click, new, create a file, and the file name is search screen. And in this search screen, I'm gonna write my composable. So first composable is search screen. Just below to it, I'm gonna create one more composable, naming search screen content. And in the search screen content, we're gonna pass our UI state. So just pass as a parameter search UI state. And I'm gonna use within this scaffold, and in this scaffold we're gonna pass modifier fill max size. We have top bar. So in place of top bar, I'm gonna use my text field so that user can enter their query. So in this text field, we want two information, value and on value change. So for the value, we'll simply pass our query. For the on query change, I'm gonna use here lambda. So in the text field, we have value. So in place of value, I'm gonna pass my query. On value change, will use my on query change. Now we have here modifier fill max width. Next we have placeholder, which contains text which says search movies. And lastly, I'm gonna use here colors, which is coming from text field default dot text field colors. We have here unfocused indicator colors, which is transparent. So use here color dot transparent. Similarly, for the case of focused, I'm gonna use here color dot transparent. Okay, so we are done with our text field. One more thing, I'm gonna use here max line 1 because in this particular text field I want to use only few letters just to search a list of movies from backend. Now in our content lambda, we'll retrieve this inner padding. We'll use here when UI state is loading. I'm gonna use box with modifier, padding is inner padding, fill max size. We have content alignment center. Simply use here circular progress indicator for the loading case. For the next case, we'll use here UI state error is not empty. On that scenario, I'm gonna use the same composable. So copy this stuff, paste in here. Instead of using a circular progress indicator, this time I'm gonna use text and simply pass my error message. Lastly, we have here UI state data. If it is not equal to null, And then I'm gonna use my data information. So within this, we're gonna use lazy column, pass modifier with padding, inner padding, fill max size. We're gonna use here items, so we have count. Now this count is coming from our data. Next we need to pass the key. So in this key we'll use data dot get. So within this key we are getting indexes, so I'm gonna use that index and mention my ID. Next we have here content type. Again in this training lambda we are retrieving the index, so data dot get, simply pass your index and ID. And I'm gonna use here item data dot get index. Okay, so now we're gonna load image from URL. So in order to load image from URL, we're gonna use a library naming coil. Go to your build gradle KTS and add dependency for that. So implementation libs coil, sync your project, come back to your search screen, subcompose async image. In place of model we need to pass our URL, so item dot image URL. But we know sometimes this item dot image URL is empty. In this case we're gonna delete later. For time being, just focus on the subcompose async image. Just paste in here. Now we have model. Next we have the loading. So in this loading we'll use modifier, fill max width. My content alignment is again on the center, and we'll use circular progress indicator. What about the height? So height is, let's say, 400 dp. So that's it for the loading. Now within this subcompose async image we have error case 2. So for the error we'll use the same thing. So copy this, paste in here, and this time we'll use a text in it which says something went wrong. Alright, pass your content description which is null. Now lastly we're gonna pass modifier. So modifier fill max width, height is 400 dp, and at the end I'm gonna use here clip a rounded corner shape of 12 dp. Alright, one more thing, let's use padding. So horizontally I'm gonna use here 12 dp, and from the top I'm gonna use here again 12 dp. Alright, so what will happen if image URL is empty? Again I'm gonna use here modifier fill max width, padding horizontally I'm gonna use the same 12 dp, and padding top I'm gonna use the same 12 dp. Next we have content alignment which is on the center, and in this I'm gonna use text which says no image available. So that's it, this is my list item. Okay, now scroll up, it's time to use this search screen content. So use it, specify all of the remaining argument, pass modifier fill max size in place of UI state. First let's create view model instance with the help of Koin view model. Mention the type which is search view model, remove this pair of parentheses with rounded brackets. Next we'll use UI state. So UI state by view model UI state, collect this thing in a form of state attached to the composable lifecycle. Now simply pass this UI state. So in place of query, again we need to use query. Coming from our view model query, collect this thing in a form of state attached to our composable lifecycle, use query. Next we have on query change, use your view model update query. Alright, so we are done with our search screen. Now it is a good time to set up navigation for Android. So to do that, go to your compose application, and in this I'm gonna create a package, and the package name is navigation. Let's add dependency for this navigation in our build.gradle.kts. Scroll up in the Android main, implementation, lips, compose. I think we have navigation.compose. Sync your project, go back to your navigation package, and after the sync is completed, I'm gonna create here a file, and the file name is base navigation graph. This is an interface, and in this interface we're gonna write a blueprint. We have a function name is build. We'll pass here modifier. We will pass here nav controller, import this nav host controller, and lastly we're gonna pass here nav graph builder. Alright, so for each feature I'm gonna create here a different navigation graph. So we have two features, like search feature and detail feature. So for the search feature we have a different navigation graph, or you can say nested navigation graph. For the detail we have a separate nested navigation graph. So right click, this is an object which says search nav graph, and this search nav graph object uses base navigation graph override build, and on top of this I'm gonna use your seal interface destination. We have two destinations, so the first destination points toward our nested navigation, and next will contain the information about the screen which is present in this nested navigation graph. So we have search, and if you want to use here type safe navigation, make sure to annotate this thing with serializable. Okay, scroll down, now it's time to use it. So we have here nav graph builder which contain a function naming navigation, and this navigation function is used to create small nested navigation graph. So the nested navigation graph destination is dest.root, and in this we have start destination which is search. Now I'm gonna use composable, and in this composable I'm gonna mention my search destination, pass modifier. Alright, so what will happen if user click to the image? On that scenario I want to perform navigation from this screen to detail screen. So to do that I'm gonna add here on click naming lambda which contains the ID information. Scroll down, similarly copy this lambda and paste within our search screen content. So on click. Now scroll down, go to your sub compose async image. We have here modifier, and just before to our clip I'm gonna use here clickable. On click and pass my item ID, import it. Alright, so now go back to your search navigation graph. We have on click which will provide us my movie ID, and we're gonna use this thing later. Okay, so we are done with this small nested navigation graph which is search navigation graph. Now it's time to create navigation host. So remove all of this thing from here, use navigation host, and the requirement of this navigation host is nav controller. Create nav controller with the help of remember nav controller and simply pass it nav controller. Next we have here start destination, and basically I want to start my application journey from search screen. So we'll use here search navigation graph dot destination dot root, and within this I'm gonna create a list of base navigation graph. We'll use our search navigation graph in it, and for each loop I'm gonna use my build function. So this build function is actually used to attach all of our small nested navigation graph to this big navigation host. Requirement of this thing is modifier, so simply pass modifier fill max size. Next we need to pass our nav controller and nav graph builder. Alright, so we are pretty much done with it. Remove this show content. Alright, so yeah, we are pretty much done. Now I think we are going to execute this application and see whether it is working or not for Android platform. So select the target. So when you click on it, you will see two targets for Android and for iOS. So just select the Android target and execute it. Alright, so our app is executing. Okay, so app crashes. Let me see why it is crashing. Okay, so serialization exception. It says it cannot find a serializer for root. So I think we missed the plugin. Scroll up and here we need to attach the plugin for Kotlin X serialization. Okay, sync your project and re-execute it. Alright, so our app is executing. For the time being, just forgot about this padding issue. So in the search movie, let's say I'm searching here Harry. We have few issues. Okay, so the issue is this token. I didn't copy my token properly. So just paste it with the correct authorization token. And now I'm going to re-execute my app. Okay, so now I'm gonna use Harry. Image is coming. Basically the data is coming from the API. Oh, I got the issue, and the issue is related to coil image loading library. So in coil image loading library, under the hood it uses Ktor client. So we need to add one more dependency which is for the Ktor. Okay, sync your project, and after that when you execute your application it will work. Okay, so here I'm gonna use Harry. There we go. We are getting all the responses. Okay, so now it's time to fix this padding issue. So to do that, go to your compose application app. Here you can see we are using safe content padding. So I'm gonna simply remove it, and instead of using here column, I prefer scaffold more over column. And in scaffold we have inner padding. Now use this inner padding here. Alright, remove this horizontal alignment because this is not available within our scaffold. Re-execute our application. Okay, so as you can see, now padding issue is gone, and I'm gonna type here Harry. Okay, so this image won't take all of the width, so let's fix it. So to fix it, it's very easy. We need to add content scale in our lazy column list item. So search, scroll down, just make space. Okay, so here as you can see we have sub compose async image which has content scale, and in this content scale I'm using crop. Re-execute our application. Okay, Harry. Okay, so now you can see it takes all of the available width, and also we have a rounded corner. Alright, so we are done with our search feature. Now it's time to continue our journey for detail. So scroll up, minimize core and feature, and also minimize this compose app. Now in this feature we have detail. So let's begin our journey with detail data layer. Go to your build.gradle.kts and establish connection. So implementation, projects, feature, not feature, we need to establish connection with our core network, and also we gonna attach Koin DI framework. Now in this data layer I'm gonna create common main directory. Now we will create package which is Himanshu, and this time feature name is details. So use here details data. Scroll down, open up your domain, and in this domain let's create directory for common main and also package. right click, new package is dev himanshu details domain. Now in this domain I'm gonna create here package for domain layer model. Next package is for repository interface, and last package is for our use cases, and also we'll use here di, so create a package. Now in this model I'm gonna create data class, and the data class name is movie details, and in this movie details we have id, type of this thing is string, we have title, type of this thing is string, and we have overview, type of this thing is also string, and lastly we have image url, type is string. Now in this repository I'm gonna create here an interface naming details repository, and in this we have a function naming suspend function get movie details, pass the movie id, and return type of this function is result, type is movie details. Alright, so now it's time to provide its implementation. So to do that, go to your data layer, build.rel.kts and establish connection. So we have here features, details, domain, sync your project, and in this data now I'm going to create a package for repository, and in this repository we have a class, and the class name is details repo implementation, which uses our details repository. And in this detail repository implementation we gonna inject our service, so private val service, type is movie API service, implement the method get movie details. We'll use here return service get movie details, pass the id, and we gonna map this movie detail response type to movie details. So movie details specify all of the remaining argument. We'll have here data.id, convert this thing in a form of a string. We'll have here data.title, we'll have here data.overview and data.poster path. So I'm going to copy the same function which we were using in our search feature data layer. So scroll down, open your search data source repository implementation, and copy this function, paste within our detail repository implementation and use it. Build image url, and if it is null just pass here empty string. Make sure this is nullable because sometimes our API provide this poster path as null. Okay, so we are done with the repository implementation. Now it's time to provide it. So for that just create a package. Package name is ti, and in this ti I'm going to create a file, and the file name is details data module. We have function get details data module, type of this thing is, the return type of this function is module, return module single instance of our details repo implementation, just inject the service, and that type of this thing is details repository. Alright, so we are done with this get details data module. Now scroll down in the domain. I'm going to create here a class, and the class name is get movie details use case. In this class we're gonna inject our detail repository, import it. We have a suspend function naming execute, pass the movie id. It uses the details repository dot get movie details, pass the id. Okay, so in the di I'm gonna create here a file, and the file name is details domain module. We have function get details domain module. Return type of this function is module. I don't think so we have added dependency for this go to your build.gradle.kts, and in the common main just use here implementation lips coin core. Sync your project, come back to your details domain module, and now I'm gonna return here my module factory which provide my get movie detail use case. Import it. Alright, so we are done with our domain module. Now it's time to begin our journey with UI. So first thing first, I'm gonna just use all of the things which we were using in the search UI. So search UI build.gradle.kts, scroll up, copy all of the plugin, come back to your detail UI, and in the plugin section simply paste it. Similarly, when you scroll down, you will see all of these dependencies. Just copy everything and paste within your detail UI. So we are dependent on feature details domain, so it contains everything. Alright, syncing is done. Now in this UI, I'm gonna create my directory for common main, and in this common main, let's create package which is dev Himanshu, feature name is details, layer is UI. In this I'm going to create a class, and the class name is details view model, and I'm going to use view model which is coming from this one. Next I'm going to create here a UI state holder class, details UI state. We have is loading, type is boolean. Next we have error, type is string, and lastly we have the movie details, initial value is null. Import it. Go back to your detail view model, and within this I'm gonna create here UI state, mutable state flow, pass your view model scope in it and the details UI state. Just below to it I'm gonna create here UI state, type of this thing is state flow, detail UI states. Make sure to use here native coroutine state. We have a function naming get movies which eventually hit our backend API. So as soon as we'll trigger this function, we'll use UI state update details UI state is loading is true. Next we're gonna use our use case. So for that we need to inject it. So private while details use case, get movie detail use case, use it, execute, pass the ID. On success will retrieve the information, UI state update, use here details UI state, and if anything goes wrong we'll use on failure. So just copy this, paste in here. Instead of using movie detail we'll use here error and pass the error message to string. So execute this suspendable function. I'm gonna use here view model scope dot launch, import this launch. So we are done with our detail view model. Now it's time to provide it. So to do that, in this UI I'm gonna create a package naming DI, and in this DI I'm gonna create a file, and the file name is details UI module. So we have here expect function get details UI module. Return type of this function is module. Now we are going to write its actual. So first for Android main, and in this Android main I'm using return module view model. Make sure this view model is coming from Koin. Details view model, inject the use case. Go back to your detail UI module and write one more actual for iOS. So in the iOS I'm gonna use here private variable view model module, and in this module I'm gonna use factory naming detail view model, inject my detail use case and use it in here within our get detail UI module. So use here a return mention the view model module. Just below to it, I'm going to create a class details view model provider, which extends Koin component. We have a function naming provide details view model. Return type of this function is details view model, and simply use get, which is an extension over Koin component. Alright, so we are pretty much done with our get details UI module actuals. Go back to your detail view model. We have a problem, and the problem is this: remove this last parenthesis. And we are pretty much done with this UI layer. So now I'm gonna write Android user interface. So in this UI, I'm having a screen naming detail screen. This is a file, and in this file we have composables. So first composable is detail screen. Just below to it, I'm having one more composable naming detail screen content. And in this detail screen content, we'll get the UI state, which is detail UI state. We'll use here scaffold, and in this scaffold we'll receive inner padding. I'm using here when UI state is loading, we'll use the same composable. Box having modifier, padding, inner padding, fill max size, and the content alignment is on the center. And within this we have circular progress indicator. That's it for the loading case. Similarly for the error, I'm using the same composable. So UI state error is not empty. Then I'm going to copy this stuff, paste in here. Instead of using circular progress indicator, this time I'm going to use here text, which will show us the error. Okay, scroll down. Now we have UI state movie detail. If it is not equals to null, on that scenario I'm going to create my design. So we will use here column modifier, padding is inner padding, and fill max size. Also I want to make this thing vertical scrollable, so remember scroll state. In this column, first I'm gonna use coil image loading library. So subcompose async image in place of model. I'm gonna pass my movie detail information. So we have here, let me create a variable so that for me it's very easy to take reference. Yeah, now it's time to use it. Movie details, we have here image URL. Next we have a loading case. So I'm using here box with modifier fill max width, height is 600 dp, and the content alignment is on the center. So alignment is on the center. Within this we'll use circular progress indicator. Similarly for the error, I'm using the same composable. So just copy this box, paste within our error, and instead of using a circular progress indicator, we'll use text no image available. Next we're gonna pass here content description, which is null, and the content is scale, which is crop. And yeah, we are pretty much done with our subcompose async image. Lastly we will pass our modifier. So modifier fill max width, height is 600 dp. I'm gonna attach here spacer. Modifier height is 16 dp. We'll use here text, and in place of text I'm using my movie details title, and I want to change its style, which is coming from our material theme dot typography headline large. I'm using modifier fill max width, text align is start. This is my text. Also let's use here padding horizontally of 12 dp. Just below to it again I'm gonna use here spacer having modifier height, this time is 12 dp. Just below to it I'm gonna use here text, and in this text I'm using my movie detail overview. Leave the style. Lastly, use modifier padding horizontally is 12 dp, fill max width, and the text align is start. Just below to it I'm gonna attach one more spacer just to make space at the bottom, so height is 64 dp. Okay, so that's it. This is our detail screen content. Now in this I'm gonna use my view model. With the help of Koin view model, create an instance of it, which is details view model. Just below to it we have our UI state, view model, UI state, collect this thing in a form of state attached to our composable lifecycle. Use our detail screen content, specify all of the argument by name, pass modifier and UI state. Alright, so now it's time to use this detail screen in our Android application. So for that, go to your compose app, source, Android main, Kotlin, navigation, and in this navigation I'm gonna create one more object, details nav graph. This detail nav graph will use our base navigation graph. Alright, so use nav graph builder navigation, and at the top I'm gonna create here a seal interface naming destination. We'll use here serializable data object root. Next we'll use serializable data class details, and in this we'll pass our movie ID. So use here variable. Alright, so scroll down and in the navigation just mention the destination route, and the start destination is dest.details class. We'll use our composable destination details, import this composable, and in this we will use our details screen, import it, pass the modifier, and also we need to pass this movie ID. So in order to get the movie ID I'm gonna create a variable it.toRoute, mention the route which is destination.details, and in this we have our movie ID, so simply pass it. Go back to detail screen, pass the ID, type of this is string, we have here launch effect, simply use ID as a key, and use your view model dot get movie, pass the ID. Go back to your detail navigation graph, and we are pretty much done with the build. Open your application.kt, and in this list simply attach your details navigation graph. Go to your search navigation graph, so when user click on it we will perform navigation. So nav controller navigate, use details navigation graph dot destination dot detail and pass the movie ID, so it will perform the navigation for us. Alright, so now I am going to execute my application, but before that we need to register all of our module within the Koin dependency injection framework. So scroll down, we have here shared, and in this shared we have app DI setup, and in this app DI setup we'll use our get details UI module, get details domain module, get details data module. So now I'm going to execute it. Alright, so use here Harry, click on it and you will see the details. Alright, so it is working in Android. So now we are going to start our journey for iOS application. Before starting our journey for iOS platform, we need to understand how Kotlin Multiplatform Project exposes all of the shared code base to iOS platform. So when we start executing Kotlin Multiplatform Project for iOS, Gradle uses native Kotlin compiler to create an Objective-C, which is Swift compatible framework, and this framework contains all of the information which we want to share with our iOS platform. So for the single module, it is fine because when we create our Kotlin multi-platform project, we have only one shared module, and this shared module is also called umbrella module. Now what will happen if we have multiple module? Like in our case, we have core module, we have feature modules. In this scenario, we need to explicitly mention these modules to our iOS targets that include this module while building your shared framework. So to do that, open up your shared module build.gradle.kts, and this is the iOS target, which target three specification for iOS x64, ARM64 and simulator ARM64. As you can see, within the framework will have the base name which is shared, and in this I want to mention to include all of my other modules. So we'll use here export project, and in this we'll provide the path which is core network. Duplicate it. Next we gonna mention the feature modules. Feature, we have first search feature, mention the data module. Next we have domain module, and lastly we have our UI module. Duplicate it. Next feature is details, detail data, domain and user interface. Sync your project. Next we need to change the target from Android to iOS and build this project. So here you can see we have a small hammer icon. Just click on it and it will build the shared framework for us that includes all of the information which is present in our feature module and core modules. Alright, so it is done. Now let me show you the framework. So for that, in the shared build we have xcode -frameworks. Open it. We have debug iPhone simulator 18.5, and here you can see this is our shared framework which contains all of the information which is present in this module and also within our shared module. Alright, so now it's time to open our iOS application on Xcode IDE. Open your Xcode IDE, open existing project, and here we have Kotlin Multiplatform Movie Search App -multi module. In this we have iOS application. Open it. Alright, so this is our iOS application. Now in this iOS application, first let me show you the general specification of this application. So you can see supported destinations. So it supports iPhone, iPad, Mac and Apple Vision. Minimum deployment is iOS 18.2. Identity is none. Display name is nothing. Bundle identifier is Dave Himanshu movie search app dot movie search app. Version is 1.0. Build is 1. Here we have few deployment info, like it supports the portrait orientation, landscape left, landscape right. We have iPad orientation, status bar style. So if you want to change it, you can do it within this development information. Next we have app icons and launch screen, frameworks, libraries and embedded content. So we will use this thing when we create modules within our iOS application. Alright, so these are the basic things that you should know when you start working with Xcode. Now I want to create here my modules. So basically we're gonna create here feature folder, and that feature folder contains two modules. First is for our search and second is for our details. So to create a module in Xcode, just click on the file, new. We have here package, choose library, click on next. Testing system is none, click next, and here you can provide the name of your library. So first we have search user interface, and I want to create this module within my desktop. Create it. So this is my search UI module. This is called manifest file, which contains all of the information for our search UI module. Next we're gonna mention here platform which is required to execute this module. So for iOS I want to choose here version 11. Okay, Just press Ctrl Save to save these changes, and after that in our iOS application I want to create here a folder. So right click, new folder, and the folder name is features, and in this feature I'm gonna drag and drop my search UI. Next I'm gonna create one more module for my detail UI. Next, testing system is none. Name of this module is detail UI, and I want to create this thing in my desktop. Create it. Okay, again simply mention the platform which is required, which is a minimum requirement to execute this particular module. So for iOS we'll use here version 16. For Mac OS we'll wanna use here version 11. Save it, and after that simply drag and drop this thing within our feature. Alright, so we have successfully created two modules, detail UI and search UI. Now it's time to establish connection between our iOS app and detail UI, search UI. So to do that, just click on this iOS application, click on this target, go to the build phases. We have here link binary with libraries. Just click on the plus, select your detail UI, just again click on the plus icon, select your search UI and add it. Now we have established connection between our iOS app with detail UI and search UI. So now it is a good time to see the package. So this is a package which is called the manifest file, which contains all of the information about our module. So here you can see in the package we have the name of our package, which is detail UI, the platforms, next we have products, and in this product we'll have library, and the name of this library is detail UI, which targets the specific location details UI. This is the location detail UI. Next we have one more target. So this target is actually used to target a specific classes, specific file which is present within our library or third party library which we will add in this particular module. Okay, so now it's time to add those dependencies. We're gonna use here two third party library. The first one is native coroutine third party library, and the second one is KMP observable view model. Paste just below to my product and before target. So these are two dependencies. In this dependency we have package URL is this one for native coroutines, and second package is for Kotlin Multiplatform Observable View Model. Add dependencies within my second target. So this dependency contains all of the file name which we want to use within our module, which is coming from this library. So to do that, I'm gonna simply copy this dependency. By the way, you will get all of this dependency from my GitHub repository. Link is in the description. As you can see in the package dependency section, it downloaded Kotlin Multiplatform native coroutine, Kotlin Multiplatform Observable View Model, and RX Swift. Similarly, I'm gonna copy this dependency and paste within my search UI package. Just below to this product, paste it, go back to your detail UI package and copy this dependency, go back to your search UI and paste in here. We are going to continue with our search UI. So in order to use the observable view model within our iOS application, we need to create an extension, and it is a compulsion which is mentioned in the third party library. So right click, new empty file, and the file name is specific KMP observable view model. First we will import our shared module. Next we will import KMP observable view model core, and now I want to create here an extension over KMP observable view model underscore core view model. Just remove this shared, use here view model. Okay, so now this KMP underscore observable view model underscore core view model is present within the library. So if you want to create an extension over this function, you need to use here annotation naming retroactive. Okay, so we are done with this extension. Now in the search UI we can write the search UI user interface. So first we're gonna import the shared module. Next we will import our KMP observable view model core. Again import KMP observable view model Swift UI. One more import which is specific to our user interface. And now I'm gonna create here public struct search view, use view, and in this we have our body. Make sure it is also a public variable body and make your initializer public. Okay, so now in this body we'll use our view model, which is search view model. So to use that, we'll use here state view model. This state view model is coming from this KMP observable view model Swift UI. It's a variable, name is view model, type is search view model, and we can initialize this thing with our search view model provider. Create an instance of this. In this we have a function naming provide search view model. Now in this body we are going to use our view model. So for that I'm going to use a vstack, and in this vstack on the top we have text field. Title key is search movies, and after that we want to mention binding. And in this binding we have two things, we have get and set. So for the get I'm using my view model query, and when we want to update it we will use here set, and in this set we'll use our view model update query and pass the query which user enters in this text field. So below to it I want to use here spacer. So this spacer will take the whole space of this vstack. By doing it, it simply pushes this text field on the top. So just below to it I want to write here a if condition. So view model UI state is loading. So if it is true, I want to use here Z stack, and in this Z stack will show a progress view, and this Z stack has frame, so its max width is infinity and max height is also infinity. Next we have our error case. So view model UI state error is empty. If it is false, that means we got some error from the backend. So in this case again I'm gonna use the same Swift UI, paste in here, this time use text and show the message UI state error. Okay, so we are done with the loading case and the error case. Lastly we'll deal with our success case. So if let data view model UI state data, so if it is not null it will execute this block. Now in this I want to use scroll view, and in this scroll view we will use for each we're gonna pass our data, next the ID. So ID is self, and one by one we will receive our items in this lambda. Now in this lambda we wanna use async image, and in this async image we need to pass our URL. Mention the URL which is present within our item.image URL. Next we'll receive the face. Just drag this thing within our search UI, so it should be present at the level of your search UI. And now when you build it, okay, so we have no issue. Go back to your Xcode, search UI, and now write the complete implementation for our async image. In this we'll use switch phase. We have three cases: empty, success, and failure. So for the empty I'm gonna use here a Z stack, and in this Z stack just use progress view. And if you're talking about its frame, so its max width is infinity and its height is 600. Okay, for the failure I'm gonna simply copy this, paste in here, and instead of using here progress view, this time I'm gonna use a text which says error loading image. Now in the success we'll deal with our image. So this image is coming from the URL, and I want to use here resizable so that we can perform the resizable modifier. we have scale to fill. After that we provide the frame. So if you're talking about its width, I want to use here max width, which is infinity. After that we'll talk about its height, and its height is 600. After that I want to use here padding, and at the end make sure to use clipped, otherwise nothing will work. We need to add one more default handling for this face, and in this face I want to use empty view. That's it. So we are done with this async image. I think we are pretty much done with the search view user interface for iOS. Now go to your content view, and in this content view just remove all of the things which is present within this wish tag, or remove this show content, and over here I want to use my search view. Import the module, so import the search UI. Let me check one more time our search view. So make sure everything is public, so like public, yeah, it will work. Now go back to your Android Studio and first just build it, and after that we will execute it. Build is successful. Now I want to execute it. So our app is executing, and here I want to search Harry. This is our progress view. This is the first image, and I think it is coming empty. Okay, this is our second image for Harry Potter. Then we have Dumb and Dumber. It is working. Now I want to modify the UI a bit. So first thing first, I want to use here text field style, which is rounded borders text field style. Scroll down, we have here async image. So I want to write here a condition. So if my item image URL is empty, on that scenario I want to create here a Z stack, and in this Z stack we have a text, no image URL found. If you're talking about its frame, so I'm using here max width infinity, and we have height, which is, make sure this is not a minimum height, it's a proper height. So height is 200. Else we use our async image. Alright, so now it's time to fix the padding problem. Okay, so I think 600 is very big. We'll use here 400, just change everywhere. After that I want to use padding. So scale to fill, so it will fill all of the space, and after that we'll use a frame which covers the maximum width, and just after that I want to use here padding horizontal, and lastly I want to use here clip shape. This is used to clip the shape. I will use here a rounded rectangle with corner radius, and the corner radius is 12. Now I am going to re-execute my application just to see whether all of the things are fixed or not. Right, so this is our search movies, and in this I want to type, so this is looking far better than before. Alright, so here you can see the issue was not fixed. So let's do a few more modifications. So first I'm gonna cut this thing and paste after this frame. One more thing, I want to remove this padding and put that padding after this clip shape. Okay, let's re-execute it. Alright, so we are done with the async image modification. Now when user click on this async image, I want to transfer the click event to my parent composable, which is not composable view, which is content view. So here we can perform the navigation. So to do that, go to your search UI, and in your init just add action, and this is an action of type lambda. The input of that lambda is string and output is void. Make sure to use here skipping. Okay, so now it's time to use this action. So to use that, I'm gonna create a action. Type of this thing is again same, string void, and within our init we'll use self dot action and initialize with the incoming action. Scroll down within our async image. This is the closing parenthesis. Here we'll use on tab gesture and call our action. Just use our item dot id and pass it. So now go back to your content view, and here we need to change few things. So now we'll receive here the movie ID. So instead of using here item, I'm gonna call it movie ID. Okay, so let's re-execute it. Okay, so it is working. Harry. Okay, so it is working. Alright, so now next we're gonna create one more module which will take care all of the navigation logic. In order to perform navigation in our iOS application, we're gonna create a different module that stores all of the logic which we want to perform navigation in our iOS platform. So to do that, go to File, New, Package. It's a library, and I do not want to include testing system in this module. Click on Next and give the module name, which is Core Navigation. Go to the package and mention the minimum requirement of platform. So first, for iOS we have version 16. For Mac OS we're gonna use version 11. Save it, and after that within your iOS project, just right click, create a new folder, and the folder name is Core Navigation. In this Core Navigation, just put your Core Navigation module. Okay, so now it's time to create a new file, and the file name is nav host controller. So this nav host controller is actually used to perform navigation. It's a class which extends observable object, and in this we have a published variable naming path. Type of this thing is navigation path, so it stores the information about our navigation path. Create an instance of this. One more thing, we need to import Swift UI because all of this information is coming from this module. It's time to create a function. So first function is navigate to, send the path, and type of this path is any hashable. Use your self path append and simply attach this path in it. Next we have one more function, pop back stack. This is used to remove the current screen from our navigation stack. Take the reference of your path, remove the last. Alright, so we are pretty much done with this nav host controller. Now it's time to add public access modifier. So public initializer. Similarly, we need to use public access modifier in front of our function. So public function navigate to, public function pop back stack, and also this is a public class. So we are done with this navigation host controller. Now it's time to create destination. So this destination points towards our view. Like we have here two views, search view and detail view. So search enum will points toward the search view, and detail enum points toward the detail view. So for that, I'm going to create here an empty file. Name of this file is destination, and in this destination we have a public enum destination which uses hashable, because if you see the path of our navigation host controller function navigate to, it's a hashable. So we have here case search, and we have one more case for details, and in this detail we're gonna pass string which represent the movie ID. So we are done with the core navigation logic. Now it's time to attach this core navigation to our iOS application. So click on the target, go to build phases, link binary with libraries, click on add, and attach this core navigation. Now go to your content view, because content view is the entry point, and here we will use navigation stack. And in this navigation stack we need to pass the path, and within this training lambda we need to put our start screen, which is search view in our case. So it's time to pass this path. So this path is present within our navigation host controller. So import core navigation, just create here state object private variable nav host controller, initialize with the help of nav host controller. So here in the path we'll use our nav host controller and simply pass the path. So we are done with the navigation stack setup. Okay, so path is inaccessible because I don't think so we have added public access modifier. Okay, so just use here public. Go back to your content view and now it is available. Alright, so now in this detail view we wanna attach navigation destinations. So for destination self, in this training lambda it will provide us all of the destination. We'll simply use here switch destination. We have two cases, like first case is search. So for the search I'm using here empty view because my root view is search view. Next case is details, and in this detail we will retrieve our movie ID. So for the time being I'm gonna use here text detail for movie ID. Alright, so we are done with it. Now it's time to perform navigation from search screen to our detail screen. So in this training lambda, I'm gonna use my navigation host controller, navigate to, and mention the path destination.details. Requirement of this detail is movie ID, so pass it. Okay, so we are done with this content view. Now it's time to create our details UI. So for that, go to your details module. In the details UI, just start our journey. So first thing first, we need to use KMP observable view model extension. So instead of creating that thing, I'm gonna simply copy this piece of code and here create a new empty file naming KMP observable view model and paste in it. Go to your details UI. So first we will import Swift UI. After that we will import KMP observable view model core, and also we'll use KMP observable view model Swift UI. And next we will create our view. So struct details view, which uses view, and within this we have public variable body which represents some view. So first we will create our view model. So state view model variable view model. We will use our details view model provider, create an instance of this and provide our detail view model. Okay, so now in this body I'm be using here Z stack, and within this Z stack it's time to use our view model. So if our view model UI state is loading is true, again we'll use here Z stack, and in this Z stack we'll use progress view. So if it is a case of error, so UI model UI state error is not empty, on that situation I'm gonna use here Z stack, and within this text I'm gonna show the message. So view model UI state error. Next, the success case. So if let data is equivalent to view model UI state movie details, we will use here scroll view, and in this scroll view we have v stack, and in this v stack we'll use async image. And in this async image we need to pass URL. So parameter name is string, and now it's time to provide the image URL. So data dot image URL. In this async image we have phases like the loading phase, empty phase. So it's time to tackle one by one. So phase, use here switch phase. As you can see we have empty, we have success, we have failure. So for the empty I'm using here Z stack, and in this Z stack we have progress view. It's time to attach frame. So max width of this is infinity. Attach one more frame for height. So if you're talking about height, I want to use here 600. So that's it for the empty case. Now for the success I'm using my image, make it resizable. After that we'll use frame. Max width of this frame is infinity and its height is 600. After that we'll use scale to fill. Then we simply use here clipped. So this is a success case. Now for the failure, again I'm gonna use here Z stack, and in this Z stack we have a text which will show the error message. So error dot localized description. Talking about its frame, so its frame is pretty much same, just like we did for the empty. So its max width is infinity. Next its height, which is 600. Okay. Lastly, we have to handle the default case. Just click on the suggestion and click on fix. So we have this default case, and for this I'm be using empty view. Okay, so that's it for our async image. Now scroll down, just below to it I will use spacer, and its min length is 24. Just below to it we will see the movie title. So data dot title, and I want to use here font title. Just below to it I want to use spacer. Again the min length is 12, and just below to it we have a text data dot overview. And if you're talking about its font, so this time I want to use here body, and instead of using a title use headline. Okay, so when this view is visible to our user, I want to fetch the information from our backend. So from this search screen we are getting the movie ID. So let's create here a variable movie ID. Type of this thing is string, and also we have a public initializer which will take this movie ID as a parameter. So self dot movie ID initialize with incoming movie ID. Now it's time to use it. So scroll down, just use this z stack ending parenthesis, use on appear, and in this you can use a task view model get movies and pass your movie ID. So this will give you some error message. So scroll up, and over here you can simply add this annotation in front of your shared import which says pre-concurrency. So simply add it. Okay, so we are done with the details UI for the time being. Now go back to your content view, and in this content view just use this detail UI instead of this text. So details view. This details view is not available because we didn't import it. So import details UI. Now it is available. So we have here details view. Let me just copy this name, which is details view. Okay, so the spelling is wrong, as you can see, DETAILS. Okay, go back to the content view, and now I think we can very easily import it. Details view. I think this is because of the access modifier. So use here public, go back to your content view. Okay, so now it is available. Just mention movie ID name. Okay, so we are pretty much done with it. Remove this padding, we don't want to use it. Execute our application. Okay, so app is executing, and here I'm gonna use Harry. Click on this image. So this is the detail of Harry. Alright, so here you can see it is properly working, but the UI is not looking good. So let's fix it and also add padding across this text field. So to do that, go to the search view, and this search view we have text field. Simply add here padding. Okay, so this is done. Next go to the details UI, and just before on appear you can use ignore safe area. Alright, so I think it will fix the issue. Re-execute our application. This is looking good. Also I need to add padding to my overview, and also I don't want to use this font family. It's looking bad for the title. So let's fix it. It's not a big thing, you can do it by yourself, but still let me just use here title, and for the overview I just want to use here padding. So horizontally 12. For the text, let it be on the center. Re-execute our application. Okay, so type here Harry, click on this image, and yeah, now it is looking good. Alright, so we are pretty much done with the iOS implementation too. Alright, so that's it for this video. I hope you got the clear concept how Kotlin multi-platform will work under the hood to build your application for Android and iOS. Apart from this, I hope you understand how to use multi-module projects for iOS and for Android. And also I hope you learn how to use navigation in both platforms, because it is the most crucial part of any application. Without navigation, you cannot actually create your application that looks promising to the user. Alright, so we will meet in our next video where we will discuss something new about Android. Till that, stay tuned and goodbye.